pasti beri jalan. Yakinlah kita pasti bisa. Majulah, raihlah juara. Oh, teruslah ku berkarya, teruslah berprestasi, teruslah tebar inspirasi. Semaju buang tunjukkan, Tuhan pasti beri jalan. Yakinlah kita pasti bisa. Majulah, raihlah juara. Majulah, raihlah juara. Majulah, raihlah juara. Juara.
Kampus terbaik, inspirasi, tebarkan harapan. Kampus terbaik, inovasi, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk negeri, untuk dunia, umat manusia, dan alam semesta. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Kampus terharapan, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk umat manusia. Bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Terus berpacu dalam keunggulan, lincah pembelajar untuk kehidupan. Inilah semangat baru, tekad raih kesempatan, wujudkan kampus terbaik selamanya. Masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian.
tunjukkan padaku langkah untuk maju, untuk mengukir sejarah baru. Mahasiswa, masa yang indah, berjuta kenangan dan cerita, keberimpian dan harapan. Masa ini menempa diri, raihlah ilmu dan jiwa pengabdi, senangkan dirimu membangun negeri. Kemasan masa ini lewati bersama, karya gemilang, kaya prestasi. Tuhan tunjukkan padaku langkah untuk maju, untuk mengukir sejarah baru. Mahasiswa, masa yang indah, berjuta kenangan dan cerita, bertabur impian dan harapan. Masa ini menempa diri, raihlah ilmu dan jiwa pengabdi, siapkan dirimu membangun negeri.
Bagi gue pinter itu gak cuma soal IPK, tapi juga soal sosialisasi. IPK 4 tuh gak samis banget cuy. Santai aja, nongkrong aja. Yang penting lu rajin dan percaya diri.
Halo teman-teman, kalian tahu nggak sih dari total penduduk Indonesia hanya 0,2% saja yang berinvestasi, sedangkan negara Singapura hampir 30% rakyatnya berinvestasi. Belum lagi mahasiswa saat ini akan diwariskan oleh middle income trap, di mana pendapatan akan stuck di level menengah. Sudah saatnya mahasiswa untuk fasih manajemen keuangan.
Selama 20 tahun hidup, gue tuh paling ngerasa gue banyak belajar ketika masa menjadi mahasiswa, itu masa-masa saat ini. Kenapa? Karena ketika saat ini, gue banyak banget nge-challenge diri gue, dan juga gue banyak banget ngikutin dan ngambil kesempatan-kesempatan yang gak pernah gue berani ambil sebelumnya. Jadi, gak usah takut ketika lo jadi mahasiswa untuk ngambil kesempatan ataupun men-challenge diri lo, karena itu adalah bagian dari lo belajar.
Sebagai mahasiswa, tanpa sadar pendapat kita pasti bisa merubah sekitar. Jadi, siapapun kamu, jangan pernah merasa pendapatmu sepele atau tidak berarti. Your opinion does matters. Tapi jangan lupa juga untuk selalu bertanggung jawab atas pendapat yang telah kita utarakan. So, voice your opinion responsibly and see your surroundings change.
Kemasan masa ini lewati bersama, karya gemilang, kaya prestasi. Tuhan tunjukkan padaku langkah untuk maju, untuk mengukir sejarah baru. Karya gemilang, kaya prestasi, kaya prestasi. Pada aku langkah untuk maju. Sejarah baru. Mahasiswa.
Distinguished guests, participants, ladies and gentlemen, welcome back to the International Conference on Statistics and Data Science, ICSDS 2022, Day 1.
Without further ado, we'll continue to our next agenda, that is Plenary Session 2, which will be delivered by Professor Dr. Muhammad Nur Aidi from IPB University in Indonesia and Associate Professor Dr. Epiredi Lim from Prince of Songkla University in Thailand. The session will be moderated by Mrs. Dian Kusumaningrum. Mrs. Dian Kusumaningrum has a master's degree in statistics from IPB University and is currently a lecturer at Prasetya Mulya University in the Business Mathematics program, and she's an awardee of a full PhD scholarship in the Department of Statistics and Data Science, IPB University. Mrs. Dian, you are kindly requested on screen.
Okay, thank you very much for the moderators. Assalamualaikum warahmatullahi wabarakatuh. Hello, ladies and gentlemen.
Waalaikumsalam.
Okay, hello, ladies and gentlemen. Good afternoon. As mentioned, my name is Dian, and I would first like to thank the committee for this valuable opportunity for becoming your moderator for today's second plenary session.
We are sorry, Mrs. Dian, we cannot hear your sound clearly from here.
Okay, is it better now? Test. Okay now? Hello? Test?
I think it's clear.
Okay, it's clear?
I'll give
Yes,
my
it's clear.
screen to you, Mrs. Dian.
Okay, thank you. Okay. As mentioned before, my name is Dian, and I would like to thank the committee for this opportunity for becoming your moderator for today's session. Before we start this session, can everybody give me a thumbs up viral reaction to show that you have had a great lunch and now ready for our second exciting session? Okay, so everyone is ready, right? And first of all, I would like to warmly greet our speakers for today, Professor Dr. Nur Aidi from IPB University and Associate Professor Dr. Epiredi Salim from Prince of Songkla University of Thailand, which will be our speakers for our second plenary today. Hello, Prof. Nur and Prof. Epiredi. Good afternoon.
Yes, good afternoon.
Okay, I would also like to welcome all the guests and all participants of today for the second plenary session. I hope that everyone is within good health and good spirit because this afternoon we are going to have two inspiring speakers that will certainly present very interesting and up-to-date topics, especially related in the field of health and environmental issues. But before I start, I have some information to share with all of you. First of all attendees, if it's possible, please use the virtual background. And for this plenary session will be divided into three parts, which is the first and second part. Each speakers will have around 30 minutes for presentations. And after the presentation, after all the presentation sessions, there will be a 30-minute Q&A session. During presentations, all audience, please mute your audio, and the committee encourages the audience to activate the camera whenever possible. Last but not least, we would like to encourage everyone to participate actively during the conference. Please don't hesitate to ask questions. During the Q&A, raise your hand or even drop your questions in the chat box. So, I would like to introduce our first speaker for today, which is Professor Dr. Nur Aidi, who is currently a professor at IPB University. And he has received his doctoral degree in statistics at the University of Philippines. His specialties are in special statistics and multivariate analysis. For today's presentation, he will deliver a topic entitled Statistical Analysis, Anemia, and Health Problems in Indonesia. So Prof. Nur ID, the time is yours.
Thank you, Mrs. Tian. I will share my presentation. Okay. Okay, thank you. First, I say thank you very much for opportunity presentation our research. Actually, this is part of our research in this year, especially for anemia and health problems in Indonesia. For this paper, we introduce the themes. The first one is me, Muhammad Nuraidi. The second one is Fitra Ernawati, Efriwati, Rika Rahmawati, Nunung Elsa Diana Julianti, Dian Sundari, Vivi Dealawati, Aya Yuniarsta Arifin, Santi Suryanti, Amalia Nelusna, dan Khalila Nurfadida. We are from two institutions, IPP University, and the second one is from Minister of Health, Republic of Indonesia. I will start the introduction first. Micronutrients deficiency is a common problem in developing countries, including Indonesia. Large Indonesia area with too many islands, size and the number of islands are 1,916,906 kilometers square, and the sum of island is 16,056. Uneven also population distribution. The total population of Indonesia 272 million, which 237 people are men, 134,000 are women. And the problem also low incomes. I think requires information about the mapping of regional health condition, including risk factors and causes of anemia. According to this Hersen and Bringer, 2001, Thomas and Thomas at 2002, Asoberry at 2001, Harper et al. 2003, WHO 2011, Risker et al. 2002, and WHO 2017. Infection and inflammation due to the change in serum ferritin level, serum iron, transferring saturation during the acute phase cause of iron deficiency. Increases acute phase protein also cause of the complex inflammatory process. Most frequent marker of acute phase protein is C-reactive protein or CRP. Hemoglobin is a protein contained in the red blood cell. Hemoglobin fertilin level can be used as indicator of iron deficiency anemia. Based on those, comparing the mean of hemoglobin, ferritin, CRP of a woman reproductive age between provinces is important to know a health condition between provinces. The percentage of WRA who experience anemia, somebody is called anemia if the hemoglobin lower than 12, inflammation or infection if RP greater than 5, and iron deficiency if ferritin lower than 15. In each province is also important for improving health in each province in Indonesia. In the context of handling WRA, who experience anemia, infection, and iron deficiency, it is too necessary to know this distribution pattern of WRA in Indonesia, whether the WRA distribution pattern is cluster or not cluster. If the distribution is cluster, the handling somewhat easier than the random distribution pattern. Analysis of a distribution WRA anemia infection and WRA anemia and iron deficiency was carried out in the study. The methods used are quadrant and nearest neighbor methods. In Indonesia is a tropical country with environment aspect until still problem. So WRA often experience malaria, respiratory problems, diarrhea, pneumonia, tuberculosis, hepatitis. Some of these diseases affect will WRA experience anemia or not. To answer this, the logit model was used. Also, identify of characteristics commonly found in WRA with infection needs to be done to prevent disease from reducing number of infection in WRA. One analysis can use to identify characteristic is classification analysis, namely the CHET method. Mr. Kaspers introduced the CHET method in 1980. CHET is part of automatical interaction detection used for category response variable. In this study, we use a CHET method. Okay, I think this introduction. The method, actually the data is combination of secondary data and primary data. Secondary data are 9,463 data part of 15,947 data of hemoglobin level obtained from researchers biomedical blocks in 2013, specifically in group of women reproductive age is around 25 up to 45 years old. The second primary data are 9,463 data for each of ferritin and CRP. Result of laboratory analysis of WRA serum from the same individual with secondary data. So we use 9,463 data. The step of analysis, the first one is descriptive statistic. The second was is cluster analysis. And the third one is binary logistic regression. And the fourth one is a cheat method. I will explain each one of this method. In descriptive statistic, we compute mean of hemoglobin, ferritin, CRP of the woman reproductive age province. Also, we compute the percentage of WRA who experience anemia, inflammation, and infection, and iron deficiency its province. We compare between protein for this result. And the second method is cluster analysis. The distribution pattern of WRA anemia and infection, WRA anemia and iron deficiency were analyzed by using quadrant method and also nearest neighbor method. To answer this question, data of its hemoglobin, CRP, and ferritin convert into account data. If hemoglobin level of WRA less than 12, WRA is anemia. If ferritin level is in WRA lower than 15, then WRA is iron deficiency. Also, CRP level in WRA. If a WRA greater than 5, WRA is an infection. The existing coordinate of this data was need, but we only have the coordinate of province, not for its data. We need the coordinate of province, latitude and longitude, and also number of anemia and infection together, number of anemia and iron deficiency together. From this data, measurement data, we already converted on data. The data were 2,238 WRA infection, 4,408 WRA anemia, and 2,041 WRA iron deficiency. Analysis the joint distribution of point pattern in the space use quadrant method and nearest neighbor. In nearest neighbor, we use key dot, key mold, and key cross function. The define of a key dot and key mold and key function are actually similar. We only compute the total count of S1 and S2 around of a distance, it's a variable. And we compare total key 1 to as a ordinate axis and horizontal axis is distance between the position. This is a cluster analysis. And the third one, binary logistic regression. Actually, the binary logistic regression is simple regression. We make a line between probability of success divided by probability of fail is equal P0 until P1 X1 until P7 X7. Why this 7 until 7 of X? Because the independent variable is a 7 independent variable. They are acute respiratory infection, diarrhea, pneumonia, malaria, tuberculosis lung, hepatitis, and the pregnancy condition. The response variable is 1 if the object is anemia, and 0 if the object is 0. And the check method, we use an independent variable. H1 is age, H2 is nutritional status based on BMI, X3 is gestational age, X4 is pregnancy disease distance, X5 is number of children, X6 is chronic energy deficiency status, X7 is anemia history, X8 is socioeconomic status. Dependent variable Y is infection status, 0 is infection, 1 is non-infection. This is a reference of why we use this variable. The result, the average of anemia level in each profile in table 1. We can know the Papua and West Papua as the lowest one, the average of anemia hemoglobin level in Indonesia. This problem because in this province, the average of hemoglobin is categorized as mild anemia according WHO. This is because lower than 12, lower than 12. But the others are greater than 12. The good one is not Sulawesi, because the average of HP level in Indonesia, it is the greatest one, not Sulawesi. I think I will not explain why this not Sulawesi is the greatest one. Why is Papua and West Papua is the lower one? Okay. Now the data is converted to account data. If the hemoglobin lower than 12, we count this data as 1, and if the hemoglobin greater than 12 is 0, and the computing account is percentage. Now the percentage of WRA who are enemy by the province. From this graph picture, we know Papua is most province, the largest province have anemia. Since the number, the average percentage of anemia is this province is 45.3%. Also with Papua, large also 36.7%. The West Kalimantan also still the big number, 30.5%. But the good one is Central Java. This province lowest population have anemia, since only 13.3% of the WRA has anemia, only 13.3%. Now we continue to compute average of CRP. CRP is a variable to identify of infection condition of WRA. If somebody WRA lower than 5 or greater than 5, if there the CRP greater than 5, we can estimate the object or the woman potential to infection. This is a table to the order of average CRP level. From this table, this is from 9,000 data, around 9,000 data. The East Kalimantan is the biggest one, since there is the average of CRP is 8.9. Also up to West Java. Those provinces can be estimated almost the WRA will be infection if the healthy of them is decreased. Decrease this one. This from WHO. If CRP greater than 5 is categorized potential to infection. In from the other average CRP, we have 7 provinces have potential infection of WRA, woman reproductive age. This is a problem in Indonesia, according to this data. Now, We compute the percentage of total number of women potential have infection. This one, potential disinfection, percent infection. The greatest one from this data is Kalimantan, Jakarta, Bangka Belitung. Since Bangka Belitung is Jakarta and East Kalimantan percentage infection, potential infection is the biggest one compared the other province. East Kalimantan, DKI Jakarta, Bangka Belitung, its has rate of WRA infection during childbirth at 55.9%, 70, I'm sorry, 50%, and also 38.1%. The good one, the most good is Nusa Tenggara, only 4.1% of potential infection of WRA. This one, okay. We continue to the other variable, ferritin. Ferritin start to identify deficiency of iron. If the measurement of ferritin lower than 15, the woman reproductive age potential as iron deficiency. Fortunately, from all this province, the average of ferritin is greater than 15. Yeah, greater than good, I think this one. The lowest one, 27.5, is still greater than 15. No province has average of ferritin lowest than 15, I think. Yeah. Okay, I will continue the percentage of iron deficiency. From each respondent WRA, the data of ferritin converted to as iron deficiency if ferritin lower than 15 and compute the percentage. Okay, they compute the percentage. The three largest percentage WRA with iron deficiency is in East Nusa Tenggara, Southeast Sulawesi, and Gorontalo, which have 40.5%, 40.0, and 34.3%. The good one is West Kalimantan, West Sumatra, and North Sulawesi compared the other province. Since they have only 12.0%, 12.1%, and 12.0, 12.1%, and 12.6%. Only small one, I think. This is a descriptive statistic, the result of this study. We continue of the other result, distribution of WRA with condition anemia and infection. We all the data converted to account data. Okay? To account data is already explained before. From this figure shows the data distribution pattern of anemia and infection. Infection is represented by a cycle, and while the triangle symbolizes as anemia. Anemia is more collected in the middle of the pattern, while infection data spread through the format data pattern. But still, subjectively, this is tend to cluster. Distribution two variable, anemic and infection. Now we continue with count square method. Based on statistic count square method with alpha 5%, we already reject the H0. That's mean a distributed pattern of two types of anemia and infection is tend to cluster. Both of two type the data, yeah? Anemia and infection. Also, with the nearest neighbor method, T-dot, also T-mod, also T-calls, we can conclude both of two type distribution have cluster distribution. Since this is the graph, the line blue is in below, yeah, and the black one is the line blue is theoretical, is the black one is the data. Yeah. This is the data greater the line blue. This we can conclude two type of object, anemic and infection in Indonesia is cluster. Is cluster distribution together cluster. Now we continue to the other distribution, anemia and iron deficiency. Why we analysis of the type? Since HB is the basis of to compute ferritin, the high relationship with ferritin. Also, HB is high relation with infection condition. So in this study, to analysis two type of distribution, anemic and efficient, and anemic with iron deficiency. Based on the data, the anemic more cluster in the middle pattern, while iron deficiency spread through the pattern form. But subjectively, this is can be conclude two type of distribution tend to cluster. Also, from statistic, we conclude also with 5% significancy, we can reject each zero, data spread random, but we accept each one. Yeah. So impedance of WRA anemia and WRA iron deficiency occurred in cluster. Yeah. This is also in cluster form. Also, with nearest neighbor.
Prof. Nur?
Yes.
I'm sorry, but maybe you have 2 to 3 minutes more. Is it okay? Okay. Thank you.
Thank you. From this figure, we also conclude two type of distribution also form clusters. Now the continue is a result of binary logistification. From this model, we can conclude RII, malaria, and pregnancy indicated have effect to anemia condition. And also with binary logistic in odd ratio, women reproductive age who are not pregnant have smaller chance then woman reproductive is to be anemia. WRA who are not pregnant have 0.47 chance of WRA who are pregnant to be anemia. Or pregnant women have 2.1 times chance of the women are not pregnant getting anemia. Also, WRA with anemia has malaria has a 1.9 chance to be anemia compared without malaria. Also, the RA who are RA has greater chance to be anemia than WRA who do not have RA, which times 1.291 times the chance. Also, the other result, chat analysis. From this one, we consider to note 3. If the pregnant woman without anemia, then take left of direction one, and the result note of 4. And the note categorized not infection. This is not infection, since the percentage of infection is lower than this one. The black one is lower than not the black one, white one. If the pregnant woman with anemia take the right direction, resulting in the note 5, terminal note categorized as infection. That means anemia will to increase chance infection for pregnant woman from this result. If the pregnancy woman have anemia, high chance to be infection during childbirth. I think this one. Now we conclusion. One, on average, the hemoglobin level in province of Papua, West Papua are anemia categorized. Both province has a higher percentage of anemia in WA than the others. On average, the CRP level in province of West Java, West Sumatra, North Maluku, Banten, Gorontalo, Papua, and East Kalimantan are in categories infection. The 5 most significant or the 4 percentage of WR indicate in province East Kalimantan, DKI Jakarta, Bangka Belitung, South Kalimantan, and West Kalimantan. The 5 most significant percentage of WRA who are estimated to experience an iron deficiency are province of East Nusa Tenggara, Southeast Sulawesi, Gorontalo, West Papua, Maluku, and Papua. The spatial distribution of WRA with anemia and WRA with infection is cluster. And spatial distribution of WRA with anemia, WRA with iron deficiency is also cluster. ARI, malaria, pregnancy significantly affect to WA anemia. Infection condition are closely related to WRA anemia condition. Anemia will to increase chance infection for pregnant woman. Yes, I think. Thank you to Mrs. Tian. The time is yours now. Thank you.
Okay, thank you very much, Prof. Nur ID, for your interesting presentation on updating current conditions of anemia and health problems in Indonesia, along with appropriate methods used in modeling these problems. So, all of us, for Professor Nur ID's great presentation, let's give a big clap reaction.
Thank you.
Okay, thank you, Prof. Nur. Okay, next, I would like to introduce our second presenter for today. Our second presenter is Associate Professor Dr. Apiradi Salim. I hope I pronounced the name correctly. Hi, Sawadika, Prof. Apiradi.
Yes, สวัสดีค่ะ
Okay, did I pronounce your name correctly?
Yes, correct.
Okay, thank you very much. So, Associate Professor Dr. Apiradi Salim is an Associate Professor of Department of Mathematics and Computer Science at Patani Campus in Thailand, and she has received her PhD in Research Methodology at Prince Songkla University in Patani, and her specialties are in statistical application for health and environmental sciences and also data science. For today, her presentation will be entitled Variations in Air Pollution and the Impact on Cardiorespiratory Disease in Southern Thailand. So, without further ado, Prof. Apiradi, the time is yours.
Thank you very much. So thank you very much for inviting me to be invited speaker for International Conference on Statistics and Data Science in year 2022. So let me share my my file. Everyone can see my file, right? So everyone can hear me, right?
Yes, clearly.
Okay. Okay, thank you. So let me talk about my research. This research actually got the funding from Thailand Research Fund, and the title is Air Pollutants Variations in Southern Thailand Impact on Cardiorespiratory Illness. So this is the outline of my talk, including introduction, objectives, methodologies, results, discussion, and conclusions. So let's come to see what is air pollution. From the definition from WHO, air pollution is a contamination of the indoor or outdoor environment by any chemical, physical, or biological agent that modifies the natural characteristics of the atmosphere. And these pollutants commonly consist of 6 pollutants, including carbon monoxide or CO, ozone or O subscript 3, and particulate matter including PM10 and PM2.5, nitrogen dioxide, and sulfur dioxide. So for the source of air pollution, it comes from many sources. For example, from the burning of fossil fuels, for example, electricity generation, or from transportation from many vehicles, and also from industry and households. And the other sources from agriculture, such as mainly come from crop residual burnings. Once the agriculture, they plant the plant, they will burn the crop residuals. And from the industry processes, for example, the VOC or volatile organic compounds released from the chemical industry. This also causes the problem of air pollutants. And the next one is natural resources such as the volcanic eruptions. And from the numerous negative health effects might result from exposure to excessive amounts of air pollution. It increases the risk of lung cancer, heart disease, and also respiratory infections. So the World Health Organization estimated that 4.2 million people died as a direct result from exposure to ambient air pollution in the year 2016. And geographical epidemiological disease incidents are determined by a particular region's biological and physical factors. There have never been a systematic investigation using advanced spatial modeling of cardiorespiratory inpatient department or IPD in southern Thailand. So that's why we conducted this study. The objective of this study includes to investigate the patterns and trends of air pollution in southern Thailand. And the second objective is to examine the effects of air pollution effect on cardiorespiratory diseases. Let's come to see the methodology of this study. We got the data from 3 sources. The first source, we got the daily air pollution data, which includes CO, NO2, ozone, SO2 or sulfur dioxide, PM10, and PM2.5. All of these air pollutants we got from 6 stations during the year 2016 to 2020. We obtained from these provinces in southern Thailand, as you see from the map on the right-hand side, include Surat Thani, Phuket, Satun, Songkhla, Yala, and Narathiwat province. This one we obtained from the Pollution Control Department, the Ministry of Natural Resources and Environment of Thailand. The second source, we got the number of population from 6 provinces during the same year. We download the data of population from Department of Provincial Administration, Ministry of Interior website. Admission data and population data were merged together using year and province as a key parameter. The next data source, we include the daily hospital admission from 6 provinces in southern Thailand during the same year. And this one we obtained from the National Health Security Office or NHSO. The disease includes asthma, chronic obstructive pulmonary disease or COPD, cardiovascular, and lung cancer. As I mentioned above, this data set we merge with population data together. So let's come to see the flowchart of data management and analysis. Once we got these 3 data sources, which include air pollution data, admission data, and population data. From air pollution data, we explore the distribution of this data, and also we look at the seasonal pattern by using cubic spray method to smooth the trend, and we also use ALIMA model to identify the trend of the air pollution data, and after that we use the clicking method. This method we try to predict air pollutants concentration for unknown locations. Because we got the data from the whole provinces, one province we have just only 1 station, so that's why for the admission data we got the whole from the whole province, so we have to estimate the air pollutants from the unknown location by using clicking methods. After that we merge all of these data sources together. This process exists in the data management process. And after that, we perform the descriptive analysis. And then after got the result from descriptive analysis, we use the GAM for DLMN, right? DLM is a generalized additive model for the dismuted lag nonlinear model. This one, we use a cumulative lag effect of air pollutants concentration estimated for 15 days to find the effect of air pollutant on the disease, cardiorespiratory disease. And from this one, this is a process of data analysis. And after that, we use the plot, which is called 95% confidence interval plot. This one to visualize the result from our study. So let's come to see the process of looking at the distribution of the air pollution. From the daily air pollution data, we look at the seasonal pattern by using the cubic spray. This is the formula of cubic spray method. So the plot will be like the plot from left-hand side. For example, the plot of PM10. This one, we try to smooth the trend by using the cubic spline. After that, we use the linear model, right? By using the constant that calculated from cubic spline to put as a determinants in the linear model. So we try to predict, to estimate the air pollutants concentration by using linear model. And after that, we perform the seasonally adjusted by using this formula. We minus the predicted air pollutant concentration from the observed value, and after that we add back with the mean, and we use the ALIMA model for the adjusted seasonal adjusted data, air pollution concentration data. So because of we already adjusted the seasonal pattern, so our parameter Q will be 0, and also the data has station, it is stationary data. That's why our parameter becomes 0. This one is become AR model. So this one we try to see the trend. The example as the plot, example of the plot of PM10 on right hand side as I show on the screen. And after that, we use a multivariate regression which has many outcomes, which are the pollutant concentration. And this one, the purpose, we just want to see that the average increase of air pollutant concentration in each province, as the example of the plot on left-hand side. Let's turn to the clicking method. The clicking was used to predict the concentration for air pollutants at the district level for places where the value were unknown, based on the value at known locations. So these are the process that I did. I calculate the distance and difference between each pair of locations. And after that, we group the pair of location into a space by range of distance or length. And we calculate the average and difference of each leg. And the last one, we find the best fit line for the average semi-variance. So this is the example of the map that we try to use the clicking method to estimate the unknown air pollutant concentration in each province. The map on left-hand side is the example of the map from the day first of the 13th of January in year 2000, and on right-hand side is the date 18th of January in year 2020, and the color it represent, right, represent the concentration of the air pollution, for example PM 2.5, right? We measure in microgram per cubic meter, and the lowest one will represent by the light blue, and then the green, then and the average one is represented by the yellow color, and the high concentration represented by the orange and the red color. So from here, air pollution data and emission data were merged together by using date and province as primary key, this one. And to produce the data set, we will use the merging data set for further analysis. Okay, and for looking at the air pollution trend, the seasonal curve was smooth using the cubic spline, and ALIMA model with the parameter P, D, and Q parameter of 100 was used to illustrate the trend of air pollutant concentration. Multivariate regression was used to estimate the average increasing or decreasing trends of air pollutants concentrations, as I have already mentioned. For the effect of air pollutants on cardiorespiratory diseases, we use this model, generalized additive model, or in short called GAMS. These GAMS were used to conduct a distributed lag nonlinear model, because for the a relationship between the air pollutant concentration and the disease. The prevalence of the disease might not be linear, so that's why we use this model. So let's come to see what is GAM. GAM is a ligation-based trend estimation technique that makes it possible to discover nonlinear relationship. And for the distributed lag nonlinear model, or in short called DLNM, this is a statistical method commonly implemented to estimate an exposure time response function when it is assumed that the exposure effect is nonlinear. The cumulative lag effects of air pollutant concentrations were investigated with a 15-day lag to address air pollution and its lag effect on disease. And the rate of increase in patient visit equal to a 10% rise in total of air pollution levels was used to determine the health effect of each air pollutant. So these are the methods that we use. So let's come to see the result from our study. So this, the first table, this one represents the mean of each air pollutants and the range and interquartile range. For example, the CO and O3, also ozone. These two air pollutants, we don't have the National Ambient Air Quality Standard. This one for Thailand, and also the WHO guideline, also they don't set up the standard for these two air pollutants. But this one, we got the average for CO, carbon monoxide, we have the average 0.5, right, with the SD, which is 0.1, and ozone, the average is 19.9, and the SD is 5.4. The measurement unit is ppb, or parts per million. And let's come to see the nitrogen dioxide and sulfur dioxide. These two air pollutants, the National Ambient Air Quality Standard for Thailand, we have set up it. For nitrogen dioxide, set up at 30. For the WHO guideline, set up at 21.3. And for sulfur dioxide, set up at 40. But not for the WHO. And look at here, the level of these two air pollutants much lower than the standard. But if you look at the PM10 and PM2.5, the unit is microgram per cubic meter. And the National Ambient Air Quality Standard is set out for 50 for PM10 and 25 for PM2.5. The means of the air pollutant, this one is lower than the national standard. But if compared to the WHO guideline, the mean of these two air pollutants is higher than the WHO guideline. So we, in Thailand, in southern Thailand, we have these two air pollutants that might have the problem, right? Higher than the WHO guideline. And let's see the result. The result, look at the trend. The trend of carbon monoxide, the first air pollutant. And so the plot on left-hand side, this represents the trend from year 2016 to 2020 from each station or each province. And we can see that, looking at here, there are three provinces. Here, three provinces had the increasing trend. For example, in Surat Thani, in Songkhla province, and in Narathiwat province. And from Phuket, Phuket has a decreasing trend of carbon monoxide. Here is Phuket. And for the rest, Yala and Satun, this one has the trend not different from the average. Okay. And look at the ozone. Here is ozone. And we found that Phuket, just only one station here, has the increasing trend on average, right? look at the last two provinces, Narathiwat and Yala. On the deep south, these two provinces has the decreasing trend of ozone. And the rest, these three provinces, not different from the average. Okay. And let's come to see nitrogen dioxide. Nitrogen oxide, we found that it has the increasing trend just only one province, which is Narathiwat province here. But all the rest, 5 stations or 5 provinces has the decreasing trend here, decreasing trend. So on average, if we sum it up, it's not different from the not significantly trend, but actually from these 3 provinces has a lot decreasing, right? And if look at sulfur dioxide also provide the same result with the increasing trend in Narathiwat province, but the other had the decreasing trend from other provinces. And let's come to see the PM10. The particulate matter 10. The size of a particle is 10 or less than 10. This one we found that there are 4 provinces had the increasing trend, which increased Surat Thani, Phuket, Songkhla, and Satun. This one. And only one province has a decreasing trend, which is Yala province here. Let's come to see PM 2.5. PM 2.5 also had a similar trend as PM 10, which we found that there are 4 provinces have the increasing trend on average, includes Surat Thani, Phuket, Songkhla, and Satun. And the rest not significantly different, right? So that's all the result from the evolution. Let's come to see the result from the admission data. From the admission data, we look at 4 diseases which increase asthma, cardiovascular disease, COPD, lung cancer, right? And look at here, we found that for asthma, most of patients, they were female, accounted for 61%. And for all the rest of the disease, most were males, accounted more than 59%. And look at the age group. From age group, asthma mostly occur among children aged less than 20, accounted about 49%. But for other diseases, mostly occur for old people, actually for people greater than 60 years. 60 years and older, this one. The percent is more than 60%. And for length of hospital stay, asthma has short length of hospital stay, just less than 2 days, right? Less than 2 days for about 60%. But for other disease, the length of hospital stay more than 3 days or more, which accounted more than 37%. And look at the province. For Songkhla, most of the admission are from Songkhla province, mostly from asthma, cardiovascular disease, COPD, except for lung cancer, mostly come from Surat province, right? And look at the morbidity rate per 10,000 population. We found that mostly occur in male, which accounted for 112.3. And for age group, the lowest of morbidity occur in age 21 to 40 and highest in age more than 60. And for length of hospital stay, mostly the minimum morbidity, this is in day 3 days, and highest is more than 3 days. And for the province, the minimum morbidity rate per 10,000 population occur in Phuket province and highest in Satun province. and look at the result. We look at the correlation between each air pollutants and the four diseases, and we found that for carbon monoxide has positive correlation with asthma, cardiovascular, COPD significantly, and for ozone this has significantly also correlated with COPD. And nitrogen dioxide and sulfur dioxide, these two has negatively correlated with cardiovascular disease, right? And sulfur dioxide has positive correlation with COPD, but negative correlation with lung cancer. For PM10 and PM2.5, we found that PM10 and PM2.5 has positive correlation with all diseases. And this is the final result. We look at the 95% confidence interval with the 10% increase in the air pollution concentration, right? On y-axis represent the relative risk. We calculate the relative risk, and on x-axis represent the lag, number of lag start from 0 day until 15 days. And look at asthma here. From the asthma, we found that here on day about 12 to 14, this one has significantly increasing the risk. And for COPD, for day 2 to 7 has significantly increasing the risk of getting COPD. And for lung cancer, from day 14 to 15 day, it has a significantly increasing the risk of lung cancer. And look at the for asthma, for PM2.5. PM2.5, we found that from the lag 10 to 15 days, increasing the risk of asthma. And for CBD, from lag 5 to 6, had a significantly increasing the risk of CBD. And for lung cancer, at the lag 13 to 15, it has a significantly increasing the risk of getting lung cancer from PM2.5. And let's come to see carbon monoxide. It has a significantly increasing the risk once the air pollutant increased 10% at lag 9 to 15 for lung cancer. And also for nitrogen dioxide, we found that at lag from 0 to 15, it has a significantly in higher risk of getting COPD. That's all the result from our study. And let's come to see the summary. From the carbon monoxide, it decreased from year 2019 to 2020. And ozone, it display an annual cycle with a slight negative tendency after year 2019. And both nitrogen dioxide and sulfur dioxide have declining trends. For PM2.5 and PM10, the concentration appear to be slightly rising yearly. And for the COPD, asthma and lung cancer patient visits were associated with a 10% increase in PM10 of the mean, 24.2 microgram per cubic meter. And cardiovascular disease, asthma and lung cancer patient visits were associated with a 10% increase in PM2.5 of the mean, 12.5 microgram per cubic meter. Lung cancer patient visits were associated with a 10% increase in carbon monoxide from the mean of 0.5 ppm or part per million. COPD visits were associated with a 10% increase in nitrogen dioxide from the mean of 5.9 part per billion. And From our study, we discussed that from the Portilat et al., they reported that asthma symptoms among adult patients during daily emergency visits are affected by 10% increase in PM10 6 to 7 days after exposure. Our study has a 12 to 13 days lag time for inpatient visit. It is rarely visited around 1 week compared to emergency visits. And for Canova et al., they found that a 10% increase in PM10 exposure led to the rise in COPD admission, which is supported by the finding in our study. And our findings support the research by Consonni et al., which found that a 10-fold increase in PM10 was associated with a 1.8 to 1.84 increased risk of lung cancer. And our study did not discover a significant relationship between the rising of PM2.5 levels and COPD morbidity. Unlike Bao et al., they conducted a study in year 2019 and found that an increase in PM2.5 of 10 microgram per cubic meter would lead to an additional 19% of COPD admission in Lanzhou, China. And our findings show a 10-day lag time that is 5 days late compared to visit to emergency room, which support the result from Xi et al. In year 2019. And cardiovascular morbidity in this study were increased in 10% increase in PM2.5, which support those of Gao et al. In year 2020. And the finding of our study agree with those of Lin et al. And Tiwanda et al., which found that nitrogen dioxide was associated with the increase in COPD visits. So for the final one, the pollutant, which is carbon monoxide, this is a poisonous gas that will bind to the hemoglobin when breathed in. As a result, the ability to deliver oxygen is affected, and asphyxia can be fatal. But however, no study in the literature relate a rise in carbon monoxide of 10 ppm to a higher chance of being admitted for lung cancer, which found in our study. And in conclusion, the rise of developing asthma, COPD, and lung cancer was found to increase by 10% in PM10 and PM2.5 concentrations. And lung cancer risk increased by 10% increase in carbon monoxide concentration. And 10% rise in nitrogen dioxide levels was associated with a higher risk of COPD. And the final one, we conclude that the policy proposal should be made to reduce the sources of PM10 and PM2.5 in southern Thailand and to increase public understanding of health impact prevention. So that's all for my presentation. I would like to thank to the National Science Research and Innovation Fund, Prince of Songkla University for giving the funding for this research. And also thank to the Pollution Control Department and also the National Health Security Office for providing the data for our study. So thank you for all participants. That's all my talk.
Okay, thank you very much, Professor Apiradi, for your enlightened presentation about the condition of air pollution and how it impacts cardiorespiratory disease in Thailand. So let's give a great clap reaction for Prof. Apiradi for the very nice presentation. Okay. Great. Thank you very much. And now we are going to go to the Q&A session. So I think there is a question in the chat box from Mr. Aswi. Maybe you could ask directly to the forum, please. Your question. Hello, Mr. Aswi.
Hello.
Oh, I'm sorry. I thought it was Mr. Okay. Okay, Mrs. Aswi. Sorry. Okay, please
Question
deliver your
to
question.
Professor Muhammad Nur Aidi. Actually, I already write my question, but that's fine. There are many classification tree methods. So in which condition is shade classification tree that you use, whether to be implemented over other classification method?
Okay, Prof. Nur, would you like to directly answer the question?
Okay, thank you, Ma'am Asfi. Okay, thank you. Actually, in this research, we didn't compare the method, only they use this method for anemia, only this method. We don't know if it's for this data, yeah. But our research, we compare CHART and chart, CHART, yeah. It one actually similar, I think, yeah. Close to similar, but in chart is more catching the result, yeah, catching the result, more completely the graph, more completely the picture, yeah, more completely, but the result is clear, closely the same. Only two types of the method, yeah, chart and shape. That one, the answer, yeah, maybe yes, there are many methods, yeah. I think what you like is it one you can use it. I think that one. Thank you.
Okay, thank you, Prof. Nur. Do you have any other questions, Ms. Aswi?
How do we compare? How do we choose the better model?
Okay, maybe the last question, Prof. Nur. Is it okay? You can answer.
Yes, the method compare with actually predicted, even predicted. Compare the data. The data predicted of from this method and compare it with data. How many percent it was correct and how many percent is not correct with that. Only that. It's simple, I think.
Correct classification rate,
Yeah,
maybe.
correct classification.
Okay. Thank you very much, Ms. Aswi. Okay, thank you. And we will go to our next question from Prof. Hairil. Would you like to read it, or should I read it, Prof? Okay.
You can read it. Just
Okay,
read it. No problem.
okay, I will read it. Okay, so the question from Prof. Hairil is for Professor Apiradi. In predicting the pollutant variables, did you have a chance to model using a GLMM model instead of the GAM and DLMM? Okay.
Okay, thank you very much, Prof. Hairil. So nice to see you there on the Zoom. So from my data, actually it had the problem of auto-correlations and also the spatial correlation. So that's why we try to eliminate the problem of auto-correlation, that one. And because of the problem of the relationship, it might not be linear. So that's why we turn to use a model that which is for non-linear relationship. However, from your suggestion, I also have tried that, but did not follow the assumption that I might have to transform the data, and then I might be able to use GLM in the case that I transform the data. Thank you very much.
Okay, thank you very much. Prof. Hairil, is there any other questions you would like to raise?
Oh, that's enough, I think.
Okay, thank you. Okay, thank you so much. And for the other participants, do you have any questions for Prof. Apriyadi and Prof. Nur Aidi? Please, you can raise your hand or write down in the chat box. Okay, okay, there's a question from Pak Mukhlis. Mr. Mukhlis, please raise your question. Okay.
Okay, thanks for the opportunity, Budian. My question is addressed to Dr. Apriyadi Lim. I am enjoyed your presentation, but I am curious about the formula that you use in slide 12. You use a polynomial spline, but in you use cubic in term apa? But you don't give the power of time, quadratic and cubic. Can you turn to slide 12?
Okay. Is it possible to reshare the presentation?
Okay, I will share that. Just a moment.
Yeah.
Okay.
This one? This
The
one?
seasonal pattern, yeah.
Okay.
The seasonal pattern.
Uh-huh.
The time, usually in spline cubic, the time give power quadratic and cubic, then plus smoothing term. Way to then you get the time of power 2 or quadratic and cubic.
You asked me about this term. This term, the T, right? About the
yeah. The right term is cubic, but the time in the left didn't give power T.
You mean that why don't I put this term in, right? Why I just only put this term in, right? Because we look at we cut as like a piece wide. For the cubic spline is a piece wide. We cut it. We put the knot here. We put 6 knots here. So it's just for 6. So that's why we took this one to put in this model. Right.
Okay.
Because this one is just linear term, but this is we just look at for each piece there are 6 because I put 6 knots, so there are 6 parameters that we have to estimate that.
Okay, thanks.
Thank you.
Okay, thank you, Mr. Mukhlis. Are there any other questions from the audience? Are there any other questions from the audience? Please raise your hand or you can write down on the chat box. Okay. Maybe if not, maybe I have a question for both presenters. The first question may be about what assumptions have you made when you made the model? And also maybe the second question is from the results that you have received, what kind of, are there something that's surprising for us and maybe something that we should be cautious of? Because seeing the results, it's kind of like red flag for us. So maybe you can explain a little bit more. Thank you. Maybe start from Prof. Nur.
Okay. This result is like Papua, West Papua, the average of HP levels is mild of anemia. It is a problem of Indonesia, I think. Is need to supplement of the to eat for them. It is almost in this province is mild of anemia. Also, percentage of anemia that this province, Papua and West Sumatra, the biggest one, yeah, 36.7 and 45.3. This one, this problem, yeah. Maybe this province far from Jakarta, maybe I think I don't know. No, malaria also this one the problem. Already proved in logic model. That one almost malaria also. The problem in this province. I think the research is very wonderful to examine more deeply, yeah? Especially for West Papua and also Papua. Even the assumption, I think this is the assumption only average of mean. Is no assumption, but some the number like infection, also iron deficiency. The percentage of iron deficiency, the performance is different of the average of very thin one. Why this one? Maybe I'm not select the outlier data, yeah. The lowest one, also the highest one, this one. I'm not select, I'm not delete the data, the outlier the data. Since it, for instance, almost all the provinces, no provinces average very thin. But in the percentages, iron deficiency, the big one, yeah, 40.05 for 40.0, this is the biggest one, I think. The problem, iron deficiency in Indonesia, almost in Indonesia, in this province, but in average this one. Maybe all the province there are two pool, yeah, poor people and also maybe the rich people. They want to make a difference of very thin, because ferritin is depend on the eat might eat or vegetarian eat like this. I think, yeah. Maybe my friend in this paper will answer about this condition. Maybe. No. Okay, I think this one. The type of eat, almost Indonesia can seldom eat of milk, yeah. Meat, I think. This one, yeah. Yes, Mrs. Dian.
Okay.
Your question. Okay.
Okay. Thank you very much, Prof. Nur, for your answer. And maybe next to Prof. Apiradi, please.
So, okay, thank you. For my data, because I used to actually it consists of two parts. The first part, I analyzed the evolution data by looking at its trends and the patterns. So for looking at the trend and patterns, I use the Alima model. But because of the term of the seasonal, I have adjusted since the beginning. So that's why I don't have the Q parameter. And after testing the Alima, actually it has the assumption that the data must be stationary. After testing, our data has stationary. That's why our parameter, which is D, is set to be 0. So from that one. But for the final one, I use a multivariate analysis. That's one because we take care of the problem of the spatial correlation because there are many stations. So what we try to get rid of the problem of spatial correlation. But actually it's the same as a linear model, a simple linear model. That's also the distribution of the residue must be normally distributed. We have checked for that. And for the second part, we look at the dose response of the evolution to the disease. There are 4 kinds of diseases. And this part, we use the non-linear model. So we don't care about the assumption for that. It had no assumption for that. However, from our result, we try to, actually we want to try to use some other model, for example, the machine learning model. We have looking at that as well. We want to compare that the result from using this model and from the machine learning model will be the same conclusion or not. So that is the next step that we are going to do that.
Okay. How about my experience in using station data? There's lots of missing data or unvalid data. Is it the same condition in Thailand also? And how did you solve that problem if you had those issues also?
This is a good question. Actually, we have that problem. We have the problem. However, we don't use too long data. We just use the data from year 2016 to 2020. So the system of the air pollution station in Thailand that they collect the data is quite complete. But however, we still have the problem. We impute the data. For example, we might use the median of the value and replace the missing from that.
Okay. Thank you very much. I think both of these research has a good prospect for policy recommendation. So hopefully it can be published and the government can react to the results that both of you have found in your research. Okay, thank you very much for Prof. Apiradi and Prof. Nur Aidi.
Welcome.
Okay.
Thank you.
From the audience, are there any more questions? I think not, but if you have any questions, you can email both of the authors, and I think they would be very happy to reply to your email. Okay, so I think that we have to end this session, and I would like to thank once again our presenters for today for the very nice discussion and also the sharing of the research that you have shared with us for today. And I would also like to thank the participants for their active participation. And hopefully all of these presentations today will be beneficial for everyone. Thank you very much for your attention. And for the next agenda, which is the ceremony of token appreciation, I would like to hand back to the MC. So I, as moderator, would sign off. Thank you very much. And wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mrs. Dian, and also thank you for our invited speakers in the second plenary. So before we jump into the next session, we would like to invite Dr. Bagus Sartono to give a token of appreciation for our esteemed speakers and moderator from the second plenary session. For Dr. Bagus Sartono, you are kindly requested on the screen.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, Professor Muhammad Raidi and Professor Apiradi Salim. On behalf of the Department of Statistics, we would like to deliver some token of appreciation as what is our good feeling of thanks to you for your very inspiring talk, very insightful presentation. First for you, Professor Nuraidi, thank you very much.
Welcome.
And for the second one is to you, Professor Apiradi. Hopefully in the next meeting you can come in person to Bogor again, Professor Apiradi.
Thank you. Sure will come.
Thank you very much for your talk. It's very interesting, I think, for all of the participants in our conference. Thank you very much again. And the last one is token appreciation for Miss Dian Kusumaningrum. Thank you for chairing the session, Miss Dian. And hopefully our discussion give to the participant a lot of information, a lot of new knowledge. Thank you, Miss Dian.
You're welcome. Thank you.
Yeah, I back to you, MC Amar and Zahra.
Okay, thank you for the token of appreciation that have been delivered by Dr. Bagus Sartono. Okay, before starting the final session for today, the ICSDS Day 1, we would like to remind that the Day 2 of the conference will be started earlier at 8 a.m. West Indonesian Time or GMT +7. We are honored to have 3 plenary sessions with 7 superb speakers, which are
Associate Professor Dr. Eric Vance from the University of Colorado in the USA, and Dr. Kismiantini from Universitas Negeri Yogyakarta in Indonesia in plenary session 3.
We also honored to have plenary session 4 with Associate Professor Dr. Beben Benyamin from University of South Australia, and also Dr. Anang Kurnia from IPB University, Indonesia.
We're also honored to have Dudu Fall PhD from University Cheikh Anta Diop in Senegal, and Associate Professor Dr. Asad Ahmed from King Abdul Aziz University in Saudi Arabia, and Associate Professor Dr. Arif Sobirin from the University of Leeds in the UK in the 5th and final plenary session.
So we are now continuing our meeting to the next agenda. That is a parallel session which will be conducted by the moderators on each breakout room. For presenters, make sure you join your assigned breakout room as shared on the screen. And for other participants, you are welcome to join any breakout room that interests you.
I'm sorry, I have a class 3 o'clock. Yeah. Maybe I will not join in room 1 or room 2. Yeah, I have class. Thank you.
Thank you, Prof. Nur.
Okay, Apiradi, thank you. Pak Nur, thank you.
Welcome.
Yeah. Nice to see you there. Nice.
Thank you so much.
I think for next agenda meeting apa in campus in Bogor or in PSU, I think.
Yeah, sure.
Okay, see you next time.
See you next time. Yes. Have a nice day.
Thank you again, Dr. Apiradi.
Yeah, my pleasure. Thank you.
Kampus terbaik, inspirasi, tebarkan harapan. Kampus terbaik, inovasi, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk negeri, untuk dunia, umat manusia dan semesta. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Kampus terbaik, inspirasi, tebarkan harapan. Kampus terbaik, inovasi, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk negeri, untuk dunia, umat manusia dan alam semesta. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Teraju keuangan, lincah pembelajar untuk kehidupan. Inilah semangat baru, tak teraih kesempatan, wujudkan terbaik selamanya. Oh, mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Wujudkan kampus terbaik selamanya. Wujudkan kampus terbaik selamanya. Wujudkan kampus terbaik selamanya. Wujudkan kampus terbaik selamanya.
tunjukkan padaku langkah untuk maju, untuk mengukir sejarah baru. Mahasiswa, masa yang indah, berjuta kenangan dan cerita, kabur impian dan harapan. Masa ini untuk menempa diri, raihlah ilmu dan jiwa pengabdi, siapkan dirimu membangun negeri. Kemasan masa ini lewati bersama, karya gemilang, kaya prestasi. Tuhan tunjukkan padaku langkah untuk maju, untuk mengukir sejarah baru. Mahasiswa, masa yang indah, berjuta kenangan dan cerita, bertabur impian dan harapan. Masa ini menimba diri, raihlah ilmu dan jiwa pengabdi, siapkan dirimu membangun negeri.
Bagi gue pintar itu nggak cuma soal IPK, tapi juga soal sosialisasi. IPK 4 tuh gak harus ambis banget cuy, gak harus mikir banget. Santai aja, nongkrong aja. Yang penting lu rajin dan percaya diri.
Halo teman-teman, kalian tahu nggak sih dari total penduduk Indonesia hanya 0,2% saja yang berinvestasi, sedangkan negara Singapura hampir 30% rakyatnya berinvestasi. Belum lagi mahasiswa saat ini akan diwariskan oleh middle income trap, di mana pendapatan akan stuck di level menengah. Sudah saatnya mahasiswa untuk fasih manajemen keuangan.
Selama 20 tahun hidup, gue tuh paling ngerasa gue banyak belajar ketika masa-masa saat ini. Kenapa? Karena ketika saat ini gue banyak banget nge-challenge diri gue, dan juga gue banyak banget ngikutin dan ngambil kesempatan-kesempatan yang nggak pernah gue berani ambil sebelumnya. Jadi gak usah takut ketika lo jadi mahasiswa untuk ngambil kesempatan ataupun men-challenge diri lo, karena itu adalah bagian dari lo belajar.
Sebagai mahasiswa, tanpa sadar pendapat kita pasti bisa merubah sekitar. Jadi, siapapun kamu, jangan pernah merasa pendapatmu sepele atau tidak berarti. Your opinion does matters. Tapi jangan lupa juga untuk selalu bertanggung jawab atas pendapat yang telah kita utarakan. So, voice your opinion responsibly and see your surroundings change.
Kemasan masa ini lewati bersama, karya gemilang, kaya prestasi. Tuhan tunjukkan padaku langkah untuk maju, untuk mengukir sejarah baru. Karya gemilang, kaya prestasi, kaya prestasi. Pada aku, langkah untuk maju, sejarah baru. Ku kejar mimpi, mimpi di masa kecilku. Hidup bahagia karena ada yang ku tuju. Melangkah pasti haruslah ku mulai dengan harapan. Ku mampu ciptakan masa depan. Teruslah ku berkarya, teruslah berprestasi, teruslah tebar inspirasi. Semangat juang tunjukkan, Tuhan pasti beri jalan. Yakinlah kita pasti bisa. Majulah, raihlah juara. Ku kejar mimpi, mimpi di masa kecilku. Hidup bahagia karena ada yang ku tuju. Melangkah pasti haruslah ku mulai dengan harapan. Ku mampu ciptakan masa depan. Teruslah ku berkarya, teruslah berprestasi, teruslah tebar inspirasi. Semangat juang tunjukkan, Tuhan pasti beri jalan. Yakinlah kita pasti bisa. Majulah, raihlah juara. Oh, teruslah ku berkarya, teruslah berprestasi, teruslah tebar inspirasi. Semangat juang tunjukkan, Tuhan pasti beri jalan. Yakinlah kita pasti bisa. Majulah, raihlah juara. Majulah, raihlah juara. Majulah, raihlah juara. Juara.
Kampus terbaik, inspirasi, tebarkan harapan. Kampus terbaik, inovasi, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk negeri, untuk dunia, umat manusia dan alam semesta. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Kampus terbaik, inspirasi, tebarkan harapan. Kampus terbaik, inovasi, wujudkan impian. Kampus terbaik, integritas, kuatkan tujuan. Kampus terbaik, beri terbaik untuk negeri, untuk dunia, umat manusia dan alam semesta. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Terus berpacu dalam keunggulan, lincah pembelajar untuk kehidupan. Inilah semangat baru, tekad raih kesempatan, wujudkan kampus terbaik selalu.